We shall go now for the second lecture on advanced level problems on applications of Newton's laws in circular motion. The problems may or may not involve concepts from other chapters as well. Frictional forces may or may not be present, and as usual we shall be using three types of markings. 1 dot for difficulty level 1, that's other simple problems. 2 dots for difficulty level 2, problems of moderate difficulty, and 3 dots for problems of difficulty level 3, that's rather tough or challenging problems. So let us go for the first problem in this lecture. So we consider a part of this horizontal channel of an arbitrary length L, say. This is the horizontal channel you can see, and I am taking any length of it, that is L, a part of it only. They have talked about vertical sides, as you can see, that is a rectangular cross section of width W and depth H. In my figure, this is W given, this is H given, but I have chosen L myself, only a part of this whole channel. This also is a circular arc of radius of curvature R is equal to 14 meters. So if I could show that in my figure as well, this is the center of curvature. This point is the center of curvature. Let me call this point as O of this circular arc like horizontal channel, and radius of curvature is this R. And as you understand, at any instant this channel is filled up with water, and water is entering to the left end and exiting to the right end, as I am showing in my figure. So the data is given also. Let me write them down. First of all, radius of curvature R is equal to 14.0 meter. The width of the rectangular cross section 0.600 meter. Height or depth of this rectangular cross section 0.800 meter. Also the mu, that is the mass flow rate, if the unit, if you look carefully, is kg per second, it gives me that mu is nothing but the rate of mass flow, that is dm dt. Let me write it. Dm dt is equal to 950 kg per second. And of course, the density of water rho is given to be 1000 kg per meter cube, and well-known fact. Once we understand the situation of the problem with the figure and list down the data, let us have a glimpse of how I should approach the problem. See, to get the pressure exerted by water on this channel's side walls, we have to find out the force required by the flowing water itself to be able to round this curve having a given radius, which means I require to have the mass of the water remaining inside this channel, as well as the speed with which the liquid, the water, is flowing in terms of the given data, so that you can find out the centripetal force required by the water to make this curved motion. And once we can find that force, it will be possible for us to find the corresponding force on the wall and subsequently the pressure of water on the wall. So first of all, let us find out what is the mass of water that is remaining inside this horizontal channel at any given instant. The mass of water inside the channel at any given instant is given by the product of the volume of water inside into its density. So the volume of water is equal to the volume of this channel itself. A cross-sectional area, as you can see, width of W, height of H, cross-sectional area is W into H, and a curved length of L only, which gives the volume of water inside the channel is coming out to be L into W into H, into rho outside. So I'm having here L into W into H into rho. That is equation number 1. The mass of water remaining inside the channel at any given instant. Next, they have given the mass flow rate, that is mu. Let me now understand this mu and see if I can relate it to the speed of water as it enters and exits here.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.